start recording. We are recording as we speak. Alrighty, where is Alex? Here we go. Alex is right here. Okay. And the last time we went to the student view. Yeah, that's fine. Okay, so y'all, the last time we were here, we were working on, let me make sure my mic is on. Yes, it is. Okay, and we're recording. Yes. Okay, so guys, the last time we were here, we were working on the review, and we had gotten about as far as, oh, I don't know, it looks like we had looked at some of these already because it looks like they've been clicked on. But let me come back to 22. Yes, I remember we looked at that one. Guys, I'm just going to kind of start scrolling, and see, I know you're at home, but if you got a question, don't hesitate to either turn on your mic and tell me which one it is, or throw it in the chat box, and we'll definitely get to it. Let's see. So guys, I'm just going to kind of start scrolling through. As soon as you see a question that you want me to go over, let me know what it is. I think we're probably pretty good with graphing numbers in the complex plane. I understood that part. Let's see. How do we write it in polar coordinates? That. Okay, how do we go from polar to rectangular form? So again, y'all, you see a question you want me to do? Let me know. Yes, that's what we've been doing. All right, so let's come back over here, number 22. It's okay. So we're saying, does anybody want me to go through any of these questions here? Okay. Okay, and then this is where we were right now. How do we multiply? Okay, so now let's take a look at number 29. All right, how do we find the unit vector? Anybody want us to go through it? Yeah, so look, guys, I'm going to do this real quick. I come back over here. I know I got it right. I remember. Yeah, so look, let's do this real quick. Let's pull this up here. So, you know what, let me open this guy up just so that we can, here we go, so we can see everything. Yeah, so let's see, let me get to the vector business, which is, here we go. All right. Okay, so right here, y'all, is how we can find our unit vector, right? So if I come back to my particular problem, which was right here, let me open this guy up too. This was from a different class, y'all, so it's not for us. This was us here. We were actually doing this at the end of class the other day. We talked about, didn't we? Yeah, we were talking about how to find your GPA and all that kind of fun stuff. So let's do this. So let me grab my problem right here. And right. Let me copy this guy. And let's paste it right here. There we go. So it says find a unit vector in the direction of v, which is 5i minus 12j. Express your answer in terms of I and j using only fraction or integer coefficients. Okay, so guys, I'm going to come back over here and I'm going to copy and paste this, as Luke says. I'm going to copy and paste this here from my formula sheet as well. So let me do it this way. Copy it, come back over here, paste this guy right here. Here we go. Okay, so first thing we're going to do, we're going to find the magnitude of the vector. In this case, it's v. Oops, come on, eraser. There we go. Let's find the magnitude of the vector v. So it says we're going to take the square root of a squared plus b squared. So this is going to be the square root of 5 squared plus negative 12 squared. So that's 25 plus 144, which is 169. Anybody know the square root of 169? 13. Okay. So there is the magnitude of the vector v. And so now the way we're going to find our unit vector is we're going to write it as 1 over 13 times 5 and negative 12. So this should be something like 5 over 13 and negative 12 over 13, right? But it says express our answer in terms of I and j. So wouldn't I write it like this? Wouldn't we say that uv is going to be 5 over 13i and then minus 12 over 13j, right? So let me enter that in and let's double check our answer. So right here, 5 over 13 I minus fraction 12 over 13. Yes. Okay. And check it. And we got it, right? All right, so let's get to number 30. Let's see. It says write the vector in the form ai plus bj where v has the given magnitude and direction angle. Anybody want me to go through this one? No, we're good. Okay. Okay. Anybody need us to go through dot products? Okay.
Oh, I have a question here, but you don't go. I have a question. You know, I'm not having like D1 equal like CIS and then D2 equal CIS. Could you write that as like DW and then use that for the multiply and use the dot 5 for the connected to the multiply?
Okay, so let me come back over here. Let's see.
Like as a per like as a, in the calculator, right? Like take it like the equation D equal D1 and then W equal D2 and then just use dot product to multiply.
You might want to give it a shot and see if it works. Yeah, I couldn't tell you off the top of my head for certain. Let me see. Where was that? 27 maybe. See, but these are complex numbers, right? We're not talking about vectors, right? You see what I mean? So the CIS is when you have complex numbers, not when you have vectors. Yeah. All right. What about partial fractions? Anybody need any help? Anybody want me to go through this one here? So this one, look what the instructions say for us to do. Set up the form. Yeah, this one's just setting it up, right? There you go. Okay. What about this one? Should we go through it? Anybody? Christian, Jason, you guys want me to go through it? Yeah, but this one we're actually going to do it, right? So for 32, it was just setting it up, right? So for 32, I would put, so look, if I were to do 32, I would put a over x plus 8, oops, x plus 8, and then plus b over 5x minus 4, right? And I'll check it. And that's all it's asking me to do. So for 32, it's just asking me to set it up. For 33, it's asking us, can we actually do it? So you all want me to go through 33? Okay, so let's do.
I did it by like literally looking at my notes and just like, okay, this is the steps. I don't know how this works on all the steps.
Okay, so let's see if it makes sense walking through it, so that following the steps is always a good idea, but making sure that you understand why. Okay, so I'm gonna go like this, A over, okay, the first thing we need to do is we need to factor x squared plus 9x plus 18. Okay, so remember y'all, first step, that number there's a 1. What's 1 times 18? Okay, what two numbers multiply to 18 but add up to 9? No, they have to multiply to 18 and add up to 9. There you go. There you go, okay. Right? So that's why every time I do this, y'all, in my developmental classes, I already know my number is 18, right? Just write out all the numbers you know to multiply to 18. Because once you write them all out, then it's easy to figure out which ones are going to work, right? Some people are like, oh yeah, I know it's going to be 3 and 6. But if you can't, write them all out and you'll find your pair of numbers, right? Okay, so now look, we're going to go like this, x plus 3 plus b over x plus 6. That's going to be equal to this business right here. 6x plus 15 over, and I'm going to write it in the factored form, x plus 3 and x plus 6, right? That's right, because this is what we call a rational equation. And when you have a rational equation, what you're trying to do is get rid of the fractions. And the way you get rid of the fractions is by multiplying by the common denominator. Okay, and you go 1, 2, 3. So the first time we do it, the x plus 3's are going to cancel. So we're going to have a and x plus 6. The second time we do this, the x plus 6's are going to cancel. So we're going to have b and x plus 3. And then the third time, both of these guys are going to cancel with those there, and that's going to be equal to a 6x plus 15. Okay. All right, so we're going to start multiplying out here. So we're going to go 1, 2. So this is going to be an ax plus 6a, yeah, plus bx plus 3b equals 6x plus 15. And then we can say, look, this part and this part. So ax plus bx, that has to be equal to 6x. And then 6a and 3b has to be equal to 15. Okay. And now we're going to keep going. So we're going to say, look, a plus b, yeah, equals 6. And 6a plus 3b equals 8. Okay. Yeah, we can divide everything here by 3 and make our numbers a little bit smaller. So look, let's go like this. A plus b equals 6. That's going to be a 2a plus b equals 5. All right, so now that we have that, we get to decide, what do we want to do? Do we want to substitute? Do you want to eliminate? It's really up to you.
Okay, I have some question.
Uh-huh.
So, fundamentally, A can either be, like I've solved this all out, right? A or B could be like the same number, right? And then depending on which one you just choose, to be up as B equals 6 minus A or A equals 6 minus
That's
B.
right. When you're going to solve this one here by substitution, it doesn't matter what letter you solve for. You could do the same thing here. You could solve for A or for B there too, right? But the idea is, if you're going to solve, say, this equation, which one is it easier for you to solve for? It's easier to solve for B, right? Because all you got to do is move the 2A over, right? Hold on. If you're going to solve this one, you get to choose, right? Because it's just as easy to solve for A as it is for B, isn't it? Right? So when you're going to do substitution, remember, the only rule is solve the equation for a letter. Which one do you pick? You can do any of the letters, but you want to do it what's going to be easier, right? So if you're going to do the second equation, it's easier for me to solve for B, isn't it? Okay.
I'm just asking because let's say when we get to the end of the problem that A equals 1 and B equals 1.
Well, hold on. Let's actually solve it, and this way we'll figure it out. Okay. So look, which one do you want to solve for? A or B in the top one? Okay. So B is going to be equal to what? Okay. We're going to take this value of b, we're going to plug it over here. So 2a plus 6 minus a equals 5. So 2a minus a is an a, plus 6 equals 5. So we minus 6 on both sides. A is -1, right? Now we still need to find what number? We still got to find b. So we're going to come back over here. Know that b is 6 minus a, so 6 minus a -1 becomes what, 7? So b equals 7, okay? So now that we have a and b, all we're going to do is come back to our original problem. A was -1, so -1 over x, it was plus 3, yes, equals, oh, I'm sorry, plus 6 over x plus 6. And now you're done.
So my question,
Or 7, sorry.
so, okay, my question is, could the 7 have been over x plus 3?
No,
Why not?
because remember, you're coming up with two different numbers, right? So look, do it this way. One, hold on, look, let's do it like this. Look, the question is, could it be that way, right? So look, if you were to add these two problems together, we should end up with that, right? That's what we should get. Okay, so in order for you to get these two guys together, don't we need to get a common denominator? So look, that's going to be a -x minus 6. Isn't that what I put though? Yeah, because but remember now. So look, I'm sorry, let me come back here because I am going too fast. So look, so the original problem or the original answer is -1 over x plus 3, right? Plus, I keep putting 6 in it, 7. 7 over x plus 6, right? When we add those together, y'all, what we should be ending up with is, where is it? Yes, that's what we should be ending up with, right? So look, the way we can check it is, in order for us to add these two fractions together, we need a common denominator. This is my common denominator. Okay, now look, we already had a -1 here, we already had a 7 here. What did we put down here that we didn't have before? Okay, so if we do it to the bottom, we got to do it to the top. What do we put over here that we didn't have before? Okay. So now look, when we keep going here, that's going to be a -x minus 6 plus 7x plus 21 all over x plus 3 and x plus 6, right? When we start combining like terms, isn't that going to give me a 6x? Isn't this going to give me a plus 15? Right? So now if I were to do, if we would have done this, 7 over x plus 3 minus 1 over x plus 6, and we were to do the same thing by saying, look, let's get a common denominator. We already had we already had a 7 here, we already had a -1 here. What did we put down here that we didn't have before? Okay. What do we put over here that we didn't have before? Okay. All right. Isn't this now going to give me a 7x plus 42, a minus x, and a minus 3? Okay. Isn't that now a 6x plus 39 over x plus 3 and x plus 6? Same answer, different answer? Different answer, right? So hold on, because I want you to think about this for a second. The a and the b, look where the a and the b were. The A is the number over the x plus 3. The B is the number over the x plus 6. When I'm solving my system, which letter I solve for is not important, right? What are we solving? Here we go. When we're solving our system, what letter we solve for is not important. But that number A is the number over the x plus 3, and that number B is the number over the x plus 6. And if I switch them around, it's not necessarily going to be the same thing, right?
Yeah,
So, yeah, so you got to make sure. So again, when you solve your system, how you solve your system is entirely up to you. Right now, we did substitution. If we wanted to have done elimination, we could have done elimination, right? That part really isn't important. But once you got your A and your B, then those are the numbers that we got to use. So look, we came up with A over -1, B is 7. This is the answer we're coming up with. Let's check it to make sure that we are doing the right thing. So -1 over x plus 3 plus 7 over x plus 6. You can check it. It should come out right because we actually did the math right now and it gave us the same answer. All right, let's take a look at number 34. Let's see. Questions? Anybody want me to go through this one? Solve using the addition method. What do you think? We're good with 34, anybody? Thomas, I'm going to check in with you. I haven't heard anything yet, so I'm guessing you're good. Okay, so anybody, Christian, Jason, you guys want, you're good on 34? Okay. Guys, don't be shy. If you see something that you want me to go through, tell me. Anybody? No. No. Okay. Let's take a look. 36, graph the solution set. Anybody want me to go through 36? Okay. 37, let's see. What about the graph the solution set here? Anybody want me to take a look at this one? Still good?
just do one for content I can do.
Okay. Okay.
Is that like that?
No, we can do the problem. Like I said, ask if you like
Like,
those
I know
questions.
it, but I don't want to like get to the test.
Okay, so it says graph the solution set. If there's no solution, indicate the solution set is the empty set. Okay, so let's take a look here. First thing I'm going to do, I'm going to graph the equation. Y equals 1/2 x minus 3. So like I told you all, if anything you should know already, it should be y equals mx plus b, right? Because that was drilled to us for the longest time. Okay, what is my m? What's my slope in this case? 1/2. Good. What about our y-intercept? 0 and 0 and -3. Okay, so look, we're going to zoom in right here. 0, -3 is right here. Slope is, we said it was 1/2, so that means we're going to go up 1 and over 1, 2, over 1, or up 1 over 1, 2. Okay, question. Should this line be solid or dotted? How would we know? Solid. Very good. Okay, so there's the first one. Then we'll do the same. Okay, so now once we've done that, y'all, we're going to take our test point, right? So we're going to pick a point. We can either pick in region 1 or region 2. It doesn't really make any difference, right? The reason I'm going to go with region 1, y'all, is because this point right here, the point 0, 0, is always a real easy breezy cover go point to plug in. So remember, this is my x value, this is my y value. So since our original problem was y is greater than 1/2 x minus 3, The 0 goes in for the y. The 0 goes in for the x. And so this is 0 is bigger than, that goes away. Is 0 bigger than or equal to -3? Yes, it is. Okay. So now what we're going to do is we're going to choose to shade in this area, everything up here. Okay. All right, so now we've done that. Now, let's take a look at the all right, guys, my pen is really giving up here. There we go. Okay, let's check the second equation. So second equation is y is equal to x minus 2. Okay, so we're going to do the same thing here. We're going to do a little stare and compare. Y equals mx plus b. So what's our m in this case? What's my slope? Okay, good. So remember, y'all, I'm going to think the slope is 1 over 1. What about our y-intercept? 0 and -2. Okay, let's do this line in red. So 0 and -2 is going to be right here. Since my slope is 1 over 1, I'm going to go up 1, over 1, 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 up 1, over 1. Okay. Down 1 to the left, down 1 to the left, down 1 to the left. Okay. Same thing here, y'all. That line is also going to be solid. Okay. And we'll do the same thing that we did before. Let's pick that same point. Let's pick the point 0, 0. So 0 is supposed to be less than or equal to 0 minus 2. 0 is supposed to be less than or equal to -2. Is 0 smaller than -2? No, it isn't. So that means we want to shade where the 0, 0 is not. We want to shade over here, right? Okay, so now, remember when we drew our first line, it looked something like this. We drew our second line, it looked something like this. And we're looking for the part where we overlap. So isn't this right here, y'all, my overlap? Okay. So let me come back to Alex. Part 1 of 2. What does it ask me to do? Draw both lines?
Yeah, draw both lines in the position because black.
Yeah, so let's see what I'm gonna do. So let me do my 2 points. Okay, so 0, -3, and 1 and 2 like this. There we go. And then, how do we do the shading on this deal? I guess we'll do that part in a minute. And then the second one is going to be 0 and -2. And then 1 and 1. Yeah, I did it wrong. Yeah. Okay. So 0, -3, 1 over 2. So it's up 1 over 2. There we go. That looks better. And then 0, -2, and up 1 and over 1. There we go. Shade in the region. Boom. Check it. And there we go. Okay, the solution set is not the empty set, right? Because no, the empty set would be if there was no overlap. Remember what I'm looking for? I'm looking for the overlap, right? If there was no overlap, then there would be. Well, they would be parallel, and one area would be shaded above, and the other line would be shaded where? Below, because now there's no overlap, right? What are we looking for? We're looking for the overlap. And so if there was no overlap, then we would say that would be the empty set. I would say, yeah.
Everything else is just like a circle, just a smaller circle.
Yeah. All right, so let's take a look at 38. What about centers of ellipses? We're good. 39. Center of ellipse again. Divided by 784 and go with the program. What about equation of ellipse here? Fine, okay, that's number 40. Anybody, guys? You all good? Okay, just checking. 41. What about, what's this? Is this also ellipse or is this hyperbolas? It's the same process, right? It's going to follow through with the formula stuff. Same thing here as well. And then what do we got here? Oh, parabolas, same kind of thing. And parabolas one more time. Okay. So let me do something real quick, y'all. Let me see. Let me go ahead and stop recording. Thomas, did you have any other questions that you wanted to ask? I didn't hear you, so I wanted to make sure you're okay. Are there any questions you wanted me to go over? Are you good? Okay. Okay, so hold on real quick, y'all. So let me stop recording.